Professor Bob Young here, and in this instructional video, we're going to continue our discussion of inverse functions. Now, here is the handout I talked about that was in Angel or your supplemental package that we can refer to here. So we can come back to this handout here, and we're going to start breaking it down a little bit. So in inverse functions, certain pairs of one-to-one functions that we talked about in the last video undo one another. And I like to use that word undoes for inverse functions. So notice that if we have f of x equals 8x plus 5 and g of x equals x minus 5 over 8, then let's say we plug 10 in for x in this f of x value here, and we'll get f of 10 is 85. And then notice if we take the 85 and plug it in the g function, we get 10 back. And we've talked about this concept before in the last video. So starting with 10, we applied function f and then applied function g to the result, which returned to the number 10. So look, we got a little flow chart here. So we took 10, plugged it in f, got 85, plugged 85 in for g, and got 10 back. I like that little machine-looking thing there. That's pretty cool. As further examples, check that f of 3, if we kept using those same two functions as 29, g of 29 is 3, it returns back. Negative 5 goes to negative 35, plug it in g, negative 35 comes back to negative 5, and so forth. I mean, you can do that with any values and then amaze your friends at parties. So in particular, for this pair of functions, fog, f of g of 2, the composite function gives us 2, and goff, g of f of x, gives us 2. And this is the algebraic test for inverses we're looking at now. So if fog gives us x and if goff gives us x, the composition functions, because of this property, g is called the inverse of f, and f is called the inverse of g, whenever this happens. So here is the algebraic test for inverses. If you take and you have two functions, f of x and g of x, if you plug g in for f and get x and f in for g and get x, you are talking about inverse functions, ladies and gentlemen. All right. So let the functions f and g be defined by f of x equals x cubed minus 1 and g of x equals the cube root of x plus 1, respectively. Is g the inverse function of f? So we are now going to test fog and goff here and see. So we've had this in previous sections. So what we're going to do here is I'm going to go ahead and take some colors. You know, I like to use my colors here. And we are first going to evaluate f of g of x. So we're going to take the composite function here. Remember, composite functions, you're taking functions and plugging them in other functions. We're going to take this whole cube root of x plus 1 and plug it in the f function. All right, so f of g of x here, if we took this, I'll write it right under here, and sometimes this helps students see it as well. If you take wherever you see an x and you put in the cube root of x plus 1 here, watch what happens. We're going to get the cube root of x plus 1 quantity cubed minus 1. Now, what does this cube do to this cube root? Takes it out, and down here we're left with x plus 1 minus 1. So indeed, when I take g of x and I plug it in the f function, it comes out x. That's the first half of my acid test. Now we're going to do the goff part of it. We're going to take the f part, the x cubed minus 1. So we're going to take this and plug it in g of x wherever we see an x. And what happens here is we get the cube root of x cubed minus 1. There is the f of x part plus 1. And then we can collect like terms under here. And that gives us, the ones will go out, the cube root of x cubed, which is again x. Now, since f of g of x equals x and g of f of x equals x, the algebraic acid test fog and goff, the function g is the inverse of function f. Now, a special notation is used for inverse functions. If g is the inverse function of f, then g is written as f minus 1 read f inverse. All right, so here's a little bit of new notation here. F minus 1 of x is the inverse of the function f of x. Now be careful here. Do not confuse the minus 1 in f of minus 1 with negative exponents that you have learned in the past. The symbol f minus 1 or f inverse of x does not represent 1 over f of x because remember that's the negative exponential rule. It represents the inverse function of f. So it is just a new symbol to write inverse notation. All right, inverse function, by the definition of the inverse function, the domain of f is the range of its inverse, and the range of f is the domain of its inverse. So x switches with y switches for x in inverse functions as well. All right, so let's find the inverse of a function that is 1-to-1. So they give us a function here, -2 with some ordered pairs, -2, 1, -1, 0, 0, 1, 1, 2, and 2, 2. So each x value in the function corresponds to just one y value. However, the y value 2 corresponds to two x values, 1 and 2. Also, the y value 1 corresponds to both -2 and 0. Because some y values correspond to more than one x value, f is not 1-to-1 and does not have an inverse. So the function must be 1-to-1 to have an inverse. See, so if you've got more than one of the same y values, which is shown there, or one of more than the same x values, then there is no inverse. So no 1-to-1, no inverse. Okay, now notice this next function here. It says find the inverse of each function that's 1-to-1. They give us a function g here, a set of ordered pairs, 3, 1, 0, 2, 2, 3, and 4, 0. Now here, every x value of g corresponds to only one y value, and every y value corresponds to only one x value, so g is 1-to-1. And the inverse function can be found by interchanging the x and y values. So the inverse of g, now notice they call this g inverse, g of -1, and they just take the x and y's up here and just flip them. xy becomes yx. So all of those points up top have just been interchanged. So notice how the domain and range of the function becomes the range and domain, respectively, of its inverse. Okay, now it says find the inverse of each function that is 1-to-1. So here's one graphically, or with a chart we're going to look at, a real-life example. So it says if the air quality index, the AQI, an indicator of air quality, is between 101 and 150 on a particular day, then that day is classified as unhealthy for sensitive groups. The table shows the number of days in Illinois that were unhealthy for sensitive groups selected for selected years. So notice the chart has the year 2000 to 2005 and the number of unhealthy days. So notice that the years all differ and the number of unhealthy days all differ. So you can't have any of the same there. And there won't be any overlapping part of the years because I've had students ask me that. Well, couldn't some of the years? No. All right, so it says find the inverse of the function that's 1-to-1. So let f be the function defined in the table with the years forming the domain and the unhealthy days forming the range, or we might think of the years as x and that is y there, the number of unhealthy days. So each x value in f corresponds to only one y value, and each y value corresponds to only one x value. So the function is definitely 1-to-1, and we can find the inverse simply by interchanging the x and y values. So here is its inverse. We just went ahead and we switched x and y, and that's all there is to it. All right, we're going to continue our inverse adventure in the next video. So Professor Bob Young signing off, trying to keep these videos where they're easy to digest.